Hello and welcome to WB, and we do maths here. This is your daily dose of integration. And for today's video, I have this question. This was actually asked in some IIT question asked in 1983 or something like that, 1980s. Let's keep it that way, 80s, right? And seems kind of hard, and I guess it's going to take us some time to figure out the answer. You can always pause the video and try it yourselves, and let's dive in this. Right, but I can write cotx as integration of root over tan x plus 1 by root over tan x dx, because cotx is 1 by tan x. If I take the LCM, I'm gonna have tan x plus 1 by root over tan x dx. This is nice. Now everything's in terms of tan, so I guess I can take substitution right here. Let my t is equals to tan x. So my dt is going to be secant square x dx. Hmm. So my dt by secant square x is equal is dx, and secant square x in terms of t is tan by secant square x can be written as tan square x plus 1. Tan square x plus 1 is equals to dx, and tan x is nothing but t, so t square plus 1 equals dx. Pretty cool. Let's substitute it back in our original equation. T plus 1 by square root of t multiplied by dx. Dx is nothing but dt by t square plus 1. Cool. I have to get rid of this root t. If I get rid of it, my other terms kinda seem simpler to solve. So for that sole reason, I'm gonna say root t is going to be some u. So I'm gonna have half 1 by root t dt is equals to du. That makes it dt by root t is equals to 2 du. Let's substitute it back. Integration of root t is u, so my t is u square plus 1 by, I'm going to take this part, t square plus 1. T square is u power 4 plus 1, and other part is dt by root t. Dt by root t is nothing but 2 times of du. Adding it all down back, I'm gonna have 2 times of u square plus 1 by u power 4 plus 1 du. That's pretty interesting actually. This seems like a substitution would help us if we do it the right way. What I'm going to do here is just take u square common. So I'm going to have 1 plus 1 by u square by u square of u square plus 1 by u square. And why am I doing this? Because I can just take a substitution right here. I can say some v is equals to u power 4 plus 1, because that won't satisfy my numerator, and I'm just going to repeat some multiple steps again and again, not getting to a finite answer. So if I take this somehow, if I have negative denominators, substitution might become easy, and as a matter of fact it does, you will see. So my u square will get cancelled. So 2 times of 1 plus 1 by u square plus 1 by u square du. And remember, whenever you have squares or multiples of 2 in the denominator, get a whole square out of it. That will always be handy. I mean, you cannot like normally see it, but it will come handy. So how can I take a whole square right here? This is like nothing but 1 plus 1 by u whole square. If I expand that, I'm going to have u square plus 1 by u square plus 2 into u into 1 by u. This will get cancelled, so I'm just going to have plus 2. So I'm adding 2 and subtracting 2 to get my square. So now let's see if it looks like I can just do a substitution and get the numerator. U plus 1 by u to be some v. I'm going to have 1 minus 1 by u square du is equals to dv. No, that's not what we have in the numerator, but I can do one thing that will give me, what if I have a negative right here? What about that? If I had negative, we have positive 1 plus 1 by u squared du, and that's what I have. So how can I make this negative? Negative means I have to change something right here. That means this thing has to be negative. And if that is negative, my expansion is gonna have a negative 2. So I have to add 2. And that's the change we have to do. And we got it. Almost, I'd say. So integration of 1 by v squared plus 2 dv. The rest of the numerator just becomes dv. 2 times of integration of 1 by v squared plus 2 dv. In case if we have integration of 1 by x squared plus a squared dx, it is nothing but 1 by a tan inverse x by a. You can check by differentiating this or integrating this. I'll link a video in the description for this proof if you want one. Also in the cards which you can see in the right corner. And that's about it. We just have to substitute it back now. So that's going to be 1 by root 2 because my a squared is root 2, tan inverse b by root 2, and plus c, never forgetting, root 2 tan inverse v by root 2 plus c, right? But I didn't start out with v. My v was root 2 tan inverse u minus 1 by u by root 2 plus c. Again, I didn't start out with u, so tan inverse root t minus 1 by root t by root 2 plus c. I take care of this real quick, so t minus 1 by root over 2t plus c. Have root 2 tan inverse of my t was tan x, if you can remember. Tan x minus 1 by root over 2 tan x. That's right. I'm not sure if we can simplify this further. I think we can, actually, but let's just leave it there. This is already pretty complex. And people, this was the integration of root over tan x plus root over cotx dx. That was the question. I hope you enjoyed it. Thank you for watching. If you have doubts or anything, feel free to post them in the comments. That's about this video. See you in the next one.